Good afternoon. In my presentation on the connected car, I will introduce the market to you, talk a little bit about some of the technology challenges, and share some Keysight insights into how we're enabling this exciting market. The connected car will be wirelessly connected to the internet, sharing that internet connection both inside the car and outside the car, enabling a wide range of services that you can see here on this slide. There's a wide consensus of research that points to the connected car having multiple IoT connections. In fact, every connected car that will be manufactured will be connected to the wireless internet by 2025. And Machina Research has put some numbers on this and saying that there'll be over 1.2 billion IoT connections associated with the connected car by 2025. And whilst the smartphone remains the market of scale, GSMA predict that by 2020 there'll be 3 billion LTE connections. By this same time frame, it's predicted by Gartner that there will be 250,000 connected cars. So whilst not on quite the same scale, this is a very, very exciting and very real market. And the connected car has a whole host of technology associated with it, arguably more technology than you will find in your average smartphone. When you look at some of the challenges that surround the connected car, with smartphone, most of the data is consumed when you're stationary, either in the office or at your home. Of course, with the connected car, this is a very different situation where most of the data is going to be consumed when you're on the move and arguably moving very fast. So when you look at these different scenarios here, you can imagine the technology challenges associated with delivering a premium quality of service. Looking forward to the industry itself and how the connected car is being designed. Smartphone, typically, maybe this is going on a sort of a two-year design life cycle. The connected car, as designed today, needs to be designed for a marketplace where it is going to be in service for 10 plus years. So can you imagine how you would go about designing a car for the year 2028. So this is a pretty challenging ecosystem. And also when you look at some of the design challenges, as we've had with smartphone, the connected car needs to be designed for the international marketplace. And if you pick LTE, where you have this wide range of frequencies deployed on an international basis, the connected car ecosystem also has to design this capability with the international market in mind. And where previously it's been okay to put an engineer on an aeroplane to literally field test a smartphone, when you think about the connected car ecosystem, this is a much, much larger challenge when you think about taking the connected car actually out into these different geographies to field test. In terms of the R&D lifecycle, this slide shows a lot of research that Keysight has gathered from working with partners in the connected car segment. And it shows here a 4-year design lifecycle, and this is just for one car model. And what we've learned from working with the partners in this industry is that the vast majority of test is performed in the field. And we know from smartphone that actually it's 4 to 5 times more expensive to take the bugs out of these systems during field tests, whereas you can actually get that gain if you're able to take the bugs out of the software during the R&D phase. And so, we have companies that we work with that talk about the 15-day experience, and for every software release that is downloaded into the car, the OEMs are drive testing these cars in the international markets to try and verify that these new software releases work on their connected car platform. And you can see some statistics down here in the bottom left of the slide. These OEMs are literally driving tens of thousands of kilometers to prove these new software releases in the car. And if you take a telematics unit here, for example, this is literally drive tested for every single model of car. And so if you scale up the cost of test that these companies are spending just drive testing one model, and you scale this up across multiple models, this becomes a significant test and cost challenge. So the question that Keysight poses here is really, how can this be solved during the R&D stage? And so one of the solutions that we're focusing on this year at MWC is something we call virtual drive testing. And the concept of virtual drive testing is a complete end-to-end solution for drive testing the connected car in the lab. And you can see here over on the left-hand side, the concept's very simple, that you can actually take a drive test from the field. This can be any geography, any wireless network. You can bring this into the lab and you can faithfully recreate that drive test, and then you can replay this using a Keysight virtual drive testing solution to replay those network conditions and literally drive test the car in the lab. When you think about some of the challenges of bringing the network into the lab, as I mentioned earlier, from a quality of experience perspective, there's a number of technical aspects that need to be considered, from a fast-moving vehicle having high Doppler shift through to multiple handovers, fast handovers between different technologies and indeed even different networks. All of these environmental emulation technical issues that you can see here up on this slide are all catered for in the Keysight virtual drive testing solution. So these are some particular areas that we're focused on today with our partner companies. You can see that there's a big focus on the emergency call area, infotainment, stolen vehicle tracking, and fast firmware updates over the air. So these are active projects that we have working with a number of our automotive partners. So I'd like to take you just to finish up through a case study. This is a case study of two partners that we have been working with. Both had slightly different problems. One was having issues with disappointing throughput rates, and another partner was having issues with multiple cell failures, handover failures. And so our approach here was to actually take some of the drive tests that where they were experiencing these issues. And this was in a number of different markets. You can see in the Americas, China, and Europe, we were able to bring those drive tests back into the lab. And then we were able to reconstitute those drive tests on the virtual drive testing solution. And we were able to replay those drive tests under a range of quite challenging radio channel conditions. And this was done whilst they were downloading mapping files. So these are quite large files, placing huge demand on the download capability in the car. And then from the handover perspective, there was a particular Volte handover scenario that was causing failures in LTE to 3G. This is the SRVCC handover. And through these drive tests, we were able to characterize the MIMO system in the car and highlight to the OEM in this case what the various demographics were that were causing issues in the module downloading the mapping files, and as a consequence they were able to make some modifications to improve the system. And then for the other partner, we were able to recommend some modifications to their TCU IMS configuration that enabled them to address the failures that they were having during the Volte handovers. And for both these companies now, they use these drive tests as a way of testing any new software release that is made to the vehicle before they actually release it into commercial service. Okay, thank you.